All right, let me talk for a minute about what to do with these more advanced Bohr models. As I said before, the technique that I covered in the notes and in the simple Bohr models video really only applies to elements up to argon, atomic number 18. If you go to more to 18 protons in the nucleus, then that technique just won't work right because of the way the energy levels have to be filled, something we'll learn about a little later. Calcium is one such element at atomic number 20. It goes beyond argon. It's going to require a little bit more work. When we look at the periodic table, as I've said before, there are numbers that go down the left-hand side, 1 through 7. Those are the period numbers. And they tell us how many energy levels are in the particular atom. Again, this first row belongs to period 6. That second row belongs to period 7. They fit in right in this spot right here. There are also numbers that go across the top of the table. And in physical science, you used a numbering scheme that numbered them 1 through 18, like so. In chemistry, we're going to use a slightly different set of numbers that break it down into A and B groups that actually work a little bit better for our scheme of things. Group 1 is going to be called 1A. Group 2 is going to be called 2A. Group 13 is going to be called 3A. Group 14 is going to be 4A. 15 is going to be 5A. 16 is going to be 6A. 17 is going to be 7A, and 18 is going to be 8A. And all these ones in the middle, these are going to be called the B groups. So again, group 1 is going to be 1A, group 2 is going to be 2A, group 13 is going to be 3A, group 14 is going to be 4A, 15 5A, 16 6A, 17 7A, and 18 8A. These are called group numbers. Where periods tell us the number of energy levels, the group numbers will tell us the number of valence electrons. Valence electrons are simply the electrons in the outermost level. Tells us how many electrons to put on the outside. And this is the new piece of information that we're going to have to put into our Bohr models. And again, it's going to help us push a little bit further up the periodic table. Granted, not a whole heck of a lot further up the periodic table, but maybe we can get up to, say, atomic number 36 if we do it this way. Gives us just a little bit more information, just a little bit more to work with. And what we're going to do is we're going to draw the Bohr model for calcium here. And what we're going to do is we're just going to figure out what all the pieces, what all the parts are that go into a calcium atom before we start drawing that Bohr model. We'll get this out of the way so that I have a place to write it all down. Then we're going to start with the things that we already know. We're going to start with the number of protons, the number of neutrons, the number of electrons, and the number of energy levels. First, the number of protons. That's the atomic number. Again, there are two numbers in the box. The atomic number is the whole number, the 20. This is what we use to figure out the number of protons. The number of neutrons is the mass minus the atomic number. This other number in the box, that's the mass. It's 40.078, in case you can't read it on the video. The 0 is followed by another 0, so we round it to 40. To find the neutrons, it's that mass minus the atomic number. So there are 20 neutrons in a calcium atom. Again, we're still dealing with neutral atoms. The protons and electrons will be the same. 20 protons requires 20 electrons. Energy level is period number. So again, we find our element on the periodic table, and we go all the way to the left. Calcium is in period 4, so it has 4 energy levels. It's that fourth energy level that makes things difficult, that makes this electron configuration a little different than the ones that we've already done. Drawing out the model, we have to divide these electrons up correctly, and that's the really tricky part. Making sure we put the right number of electrons in each level. And to do that, we're going to need to know how many valence electrons it has. And again, valence electrons are the number of electrons that go in the outermost energy level. To find that, we go to the top of calcium's group. Calcium is in 2A. It has 2 valence electrons. The group number, at least if you're using the A groups, the group number tells you how many valence electrons it has. So if it's in 1A, it has 1. If it's in 2A, it has 2. If it's in 3A, it has 3, and so on. Up to group number 18, or 8A, which has 8 valence electrons. And calcium is in 2A, so it has 2 valence electrons, and that's important. Here's how we draw the model. Get rid of all this. And let's draw the model. Start with the nucleus. And again, all I got to do in the nucleus is tell me how many protons and neutrons you have. 20 of each. That's the easy part. We have to draw in 4 energy levels. 1, 2, 3, 4. Here's what we want to do differently. Go ahead and put those valence electrons in. Again, the valence electrons are the ones that go in the outermost energy level. We know from the periodic table that calcium has 2 valence electrons. It gets 2 dots in its outermost level. Get those out of the way first. So we have 2 down. We have 18 to go. We put 2 there. So that's 4 down. We've got 16 to go. We put 8 in level number 2 because that's what it can hold. With 8 plus 2 plus 2. At this point, we've got 12 down. We have 8 more to go for a total of 20, and those 8 will go into energy level number 3. 8. Now, before you say, wait, Mr. Danko, you said the energy level 3 can hold 18 electrons. Well, because of the energy it takes to put 18 particles into that energy level that repel each other, we actually have to put 8 in there, jump up to the next level, level 4, put 2 in there, before we can jump back down to level number 3 again and finish filling it up. It's a little bit complicated. But again, if you use the valence electrons to figure out what's going on, it'll kind of make sense. It can get a little bit iffy when you get into the B groups. What you need to know in there is that most of the B group elements have 2 valence electrons. So if you're drawing a Bohr model for anything that I give you in the B groups, then go ahead and put 2 electrons in the outermost energy level. Okay, most elements in the B group have 2 valence electrons. There are some exceptions, but I won't give you any of those. If I give you something out of the B groups, it's 2 valence electrons. Go ahead and throw 2 in that outermost energy level, and then get at it. Fill in the rest of those in the middle. The second to the last energy level does not have to be full in a Bohr model, so that's something important to remember.